So, I want to share with you what it means for something to be a proportional relationship. I want to look at a graph though. So, if I have a graph, we have our x and we have our y axis. So, the one on the bottom is our x axis, that's our independent variables, and the one going up and down, that is our y axis. So, anytime I have an x-axis, what goes down here is the thing that is independent. So if I'm thinking about the time it takes me to move a certain amount of distance, well, time is independent of distance because time can go on and distance could either increase or decrease or stay the same. But distance is going to depend on the time. So because of that, distance is our y. So let's say distance in miles. And time is our x, and we'll say in minutes. And so I want to plot some points. Let's say this is 1, 2, 3, 4. Let's go by 50s. 50, 100, 150, 200, and so on and so forth. Now the point 1 comma 50 tells me that in 1 minute, I've gone 50 miles. No, that's a lot. Let's change minutes to hours. That makes more sense. Anywho, in 1 minute, I've gone 50 miles. Okay? And then in 2 minutes, back to hours, in 2 hours, we've gone 100 miles. Okay, and then we're going to keep continuing. In 3, I went 150, and in 4, we went 200. Now, if we were to not move at all or not have any time, then we would have no distance. So the origin in this particular case, 0, 0, that means that in 0 hours, we've gone 0 miles. Okay, in this particular situation, that's what it means. Okay? Now, if something is proportional on a graph, you should be able to make a straight line through the origin. And in this case, we are able to do that. So those are the 2 criteria when looking at a graph to tell if something is proportional. 1, it's a straight line. And 2, it goes through the origin. So if it's a straight line, if it goes through the origin, then we have a proportional relationship. Okay, and that means that we can use multiplication to find y using the x. Okay, so there's a constant of proportionality, and typically we call that k. Okay, this means constant of proportionality. And we can actually calculate the k value using any ratio of y to x. So if I go back over here, I have a series of 1, 2, 3, 4, 5 points. Okay, and my points are 0, 0, 1, 50, 2, 100, 3, 150, and 4, 200. So I can use any of these points because if something is a constant of proportionality, again, we can use multiplication and all the ratios of y to x should be proportional. Well, I never use 0, 0 because we can't divide by 0. We just know that it goes through the origin because anything multiplied by 0 is 0. But I can use any of the other points. Now remember, a point is x comma y. So if I want to find the constant of proportionality, I have to use the second coordinate, the y coordinate, first. Okay, so let's calculate the constant of proportionality using this point. Well, that's equal to our y value of 50 over our x value of 1, and that equals 50. Let's try it for this one. Our y value of 100 divided by our x value of 2, well, 100 divided by 2 is also 50. You'll see that no matter what point you use, when you take the ratio of y and divide it by the x, you're always going to get the same number. So our constant of proportionality in this particular case is 50. So in this particular case, our constant, our k, is 50. Now, if something is proportional, we can represent it with an equation. Y equals the constant of proportionality times the x value. Okay, and this is per each x. Well, in this particular problem, we saw that the constant of proportionality was 50. So the equation y equals 50x represents this situation. Now going back to x is time in hours. So if I replace the x with 1, that means I've gone 1 hour. If I replace it with a 2, that means I've gone 2 hours, and so on and so forth. So we can always replace the x with the amount of time that we were traveling. And when we take that number and we multiply it by 50, we're going to get the amount that we traveled. So let's test it out. Y equals 50 times 1. Well, 50 times 1 is 50. Hey, 1 was my x, 50 was my y. That was a point. Y equals 50 times 2. So 50 times 2 is 100. Hey, 2 was my x and 100 was my y. That's another point. You're going to see this pattern. No matter what x value you plug in, you're always going to multiply it by 50, and then you'll get its y coordinate or its ordered pair. So that's how we can write an equation of a proportional relationship. Now, we should also know that what the constant of proportionality is always going to be for one of the x's. So again, if I went back to here and I looked at this point here a little bit more clearly, one of my x's, or 1 hour, paired with 50. So on a graph, if you can see exactly what 1 is, you'll know what the constant of proportionality is. Because if for your 1x, it's always going to be what pairs with it, what y pairs with it. So our constant of proportionality was 50 here. Now, sometimes you might get something like this. Okay, so we have a proportional relationship, but when we are looking, we have like 2, 4, 6, and we have, let's say, 3, 6, and let's say 9, right? So I know that 2, 3 is a point on my graph. I know that 4, 6 is a point on my graph. And I know that 6, 9 is also a point on my graph. Now, I don't see a 2. I don't see a 1. So I can't tell just from looking at the graph what my constant of proportionality is. But again, I can use any point I want. Let's say I wanted to use this point. And the constant of proportionality is always the ratio of the y to the x. So in this case, my constant of proportionality is 3 over 2, or 1.5. That means that I can create the equation y equals k times x to represent this situation, but instead of a k, I'm going to replace it with a 3 over 2. So y equals 3 over 2 times x. So for each x, I'm going to go 3 over 2, and then I'll get to my y. So let's test it out. We said y equals 3 over 2 times x. Another point we had was 4, 6. So let's see if 4, 6 works out here. So my x is going to be replaced with a 4, and my y is going to be replaced with a 6. So 6 should be equal to 3/2 times 4. Okay, 3 over 2 times 4 is equal to, 3 times 4 is 12. Oops. So 3 times 4 is 12, and 2 times, we'll put that over 1 is 2. 12 over 2 is 6. So 6 equals 6. It worked out. Okay, so again, if you do not know your constant of proportionality from looking at the graph, you can use any point to find it. So our constant of proportionality here is 3 over 2, which means that the point 1 comma 3 over 2 is also a point on this graph. So if I was going to go over here to 1